Hello, welcome back everyone to Emoji Comes YouTube channel. My name is Godwin. What's up with you? Hope you've been having a really great day. And if you're watching this in the middle of the night, hope you've been having an amazing night. Alright, so I'm here to kind of make this night more amazing for you. If this is the platform that you want to use to understand permutation and combinations. So in our last class we started with this thing about factorials, right? And then we move into permutation a little bit, right, with some examples. And today we'll be talking about permutation properly with a lot of examples, so that a lot of different examples, like different parts of permutation, so that whenever you see questions around this, you'll be able to solve them very well, and that you are going to understand what you're doing. Now, what exactly is permutation? So, permutation is the arrangement of possible events where each order is distinct. That is, where order is important. And then I was explaining in the last class that if you have three letters A, B, and C, right, and you want to rearrange this thing, so you could have, like, you want to look at possible combinations of events. So how many arrangements can you have from A, B, and C? So I think we spent something like A, B, and C is one event. Then A, C, and B is another event. Then we're done with A, picking the other one. So you can have B, A, and C is one event. B, C, and A is another event. Then you move to C. So C into bracket A and B is one event. Then C, B, and A is BA is another event. So with the way this is going, the order is important. So in this case, we are going to be having six permutation, like possible arrangements. If you are doing permutation of this, of how many arrangements you can get from ABC, there's going to be six possible arrangements. So ABC, 1, 2, 3, 4, 5, 6. And why do we have six? Because look at the whole thing, it's just letters A, B, and C. But for permutation, whether B is coming before A or A is coming before B is important. So whether I'm standing before you on a queue or you're standing before me on a queue, it is distinct. That it's a separate event entirely. And so that is what we mean by saying that permutation considers the order of events to be important. Now, the other one that we'll be talking about next time is combination. As far as combination is concerned, it's just looking like a set of things. So, as far as there is no change in those set of things, it doesn't matter how you arrange them, it's going to be the same combination. So, in this case, like in revision, A, B, C, A, C, B, everything's talking about three letters, like just three letters A, B, and C. You didn't remove, you didn't add. So, this is all of these things will be one combination, right? Because you're using the same letters, but there's going to be six permutation because permutation considers the order of how the events are happening, right? So that's not about that. So like we want to then move into like permutation properly, looking at the formula and all of that. And let's look at a simple example. So out of 16 songs, so you have a total of 16 songs. So out of 16 songs, calculate the number of ways three best songs can be arranged. Calculate the number of ways. So we are looking at total is 16 songs. So what is the number of ways the best three songs can be arranged? So whenever I have something like this is permutation because it's considering all of the letters. So best three songs. Okay, we have 16 songs. So the chance that one song is going to come first position, like any of those 16 songs can come first position. So the first chance that any of those 16 songs can be the first that we are picking is 16. So you have 16. We introduce ourselves to this thing, in the last lesson. Now, when you've picked one of the songs, how many songs do you have left? 15 different songs. So the chance that one of those 15 different songs will be the one that will come second, so that chance is 15. How many songs do you have left now? 40. So any of those 14 songs, like, so you have 14 choices now to pick as the third song, the third position, any of those 14 choices, so times 14. And all of this is going to give us 3360 ways. Like I said, we introduced ourselves to this topic in the last lesson. Now, is there a short way that we can use to like get this particular thing? Now, the formula that we can use is that, well, how many songs do we have? 16 songs, but we are looking at the best three. So, we want to just pick 3 out of the entire 16 songs. So, a proper formula is going to be a 16 permutation 3. Now, what does this mean? 16 is 16 factorial. Now, divided by 16 minus 3 factorial. 16 minus 3 factorial. So this is going to give us 16 factorial divided by 13 factorial. Now we have 16
times 15 times 14 times 13 factorial divided by 13 factorial. 13 cancels 13. So you have 16 times 15 times 14 left, so which is still going to give us 3,360 ways. And what does this tell us? Is there a formula that we can just write out from this? So the formula for permutation basically, right, is n permutation r equals n factorial divided by n minus r factorial. So where r is representing the number of ways I can, select a set of things from the total, right? As far as foundation is, concerned. Now let us look at another example. So 6 people go to a cinema. Now 6 people. So this is like number one, number two. So 6 people go to a cinema. Now in the cinema, they sit in a row of 10 seats. So 6 people and 10 seats. Okay. So find how many ways this can be done, but how many ways can they possibly sit, right, if they can sit anywhere. So the first one is, how many ways can they possibly sit if they can sit anywhere, and two, if all the empty seats are next to each other. So if these guys can sit anywhere, they have 10 possible seats, and you have 6 people. Do you understand? So how does it work? Now the first person out of the 6 people, the person that is going, has 10 seats to choose from. So that is 10. Now, if that person has chosen a seat, then the second person has 9 seats to choose from now. 9. 2 seats are gone. So the third person has 8 seats to choose from. Then followed by 7 seats, followed by 6. 1, 2, 3, 4, 5. So the sixth person now is going to have how many seats to choose from? 5 seats. So look at the way it goes. So the first person has 10 seats in front of him. So he has 10 choices. So it's 10 times. Second person has 9 choices because one choice has been taken off. Now the third person has 8 choices. Fourth person 7 choices. Fifth person 6 choices. And then the last person has 5 choices. So if you calculate this, we are going to be having 151,200 sitting arrangement. It's 151,200 ways that these 6 people can sit on 10 chairs in a cinema, right? If they can sit anywhere, right? They don't have to like sit necessarily next to each other every time, anywhere. So using our permutation formula, since we have 10 possible seats to choose from, so we have 10 is going to be 10 permutation 6 people. So 6 out of 10. So you have 10 factorials divided by 10 minus 6 factorial. So this guy is going to give us 10 factorial divided by 4 factorial. So I'm not going to be solving this like using both ways anymore. I just want you guys to like get something. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. This takes this guy away. So if you look at it, 10, 9, 8, 7, 6, 5 is the same that we had here. So which is equal to 151, 200 ways. So you can see the way it goes. So I want you guys to understand like it's common sense. There's no need to cram like all of these things. Now this is 2A. Now for the B part is now saying that what if 4 seats, right? What is it? If all the empty seats are next to each other. So in this case now, there are 10 seats that they can choose from, right? But the first 4 seats like are next to each other. So like that means they can choose from the remaining seats. Do you understand? Like they have first four that they're probably not going to like just pick. Those are like meant to be empty seats, and then they have the 6 others that they can choose from. Now the thing that's going to happen here is that because those 4 seats are together, like they are sitting together, so they look like one big seat that is empty. Like one big seat that is empty. Like you have one big seat that is empty, right? Even though it is 4 seats, then you have 6 other seats. So which means that in this case, those 4 seats, as long as they are together, they are like one seat. Do you understand? So, and in that case, if the 4 seats must like always be together, right? So there is no way you're going to sit like you sit and there's an empty seat in between you or something like that. Those 4 seats are like together on their own, and then you guys occupy the remaining seats. So it looks to everybody as if you just be passing. You can't sit there, you can't stay, you want to go and sit here. So those 4 seats, it just look like something that you can't sit on, like one seat that you can't sit on. So I don't know like the psychology behind it. So it's just looking like one seat that you can't sit on, and then 6 seats that you can sit on. So at the end of the day, the imagination is like you have 7 seats. So a giant seat that is that wouldn't be occupied, right? And then 6 other seats that people need to like occupy. So that way, the first person out of these 10 people, out of these 6 people, is going to be having 7 choices, like the empty seats, right, and then the 6 other seats. So the logic behind that is that the first person has a choice of 7 seats, right? Second person has a choice of 6. Third person a choice of 5. Fourth person a choice of 4. Then the fifth person a choice of 3. Sixth person a choice of 2. So this one is sense that you are going to use. Now, how do we know the number of ways that these guys can sit? So just 7 times 6 times 5 times 4 times 3 times 2, because those forces must be next to each other. 1, 2, 3, 4, 5, 6. All right, so what exactly is our answer? 5040 ways. So you can see it 5040, because those 4 empty seats must always be together. So if you have 1, 2, 3, 4, and then this seat must be occupied. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It could be like this, or it could be like this. 1, 2, then this seat, 1, 2, 3, 4 have to be together. Then 1, 2, 3, 4. Do you understand? So everything is just looking like one seat that you must not sit on, nobody must sit on. So like this four seat has to be together and all of that. So like that's just logic. Like it's like a seat that nobody can sit on, a big seat, if since they are together. So like that's the logic behind that. So there is also a third similar question that we will look at a little bit. So for our third example, example 3, number 3. Number 3 says, in how many ways can 3 economics prizes be won if there are 20 contestants? So you have 3 prizes, but then you have 20 contestants. 20 contestants. So if A, no contestant may win more than one prize. So A, no contestants may win more than one prize. May win more than one prize. And then B, contestants may win more than one prize. May win more than one prize. So solution. So you have 3 prizes to be won among 20 contestants. So how many arrangements in how many ways can you get 3 out of 20 contestants? Right. So basically, this is since nobody can win more than one prize. The English behind that is that if you come first, right, you've already won that first prize, so you can't go and take second position again. And you're already taking first position, so like just cool, enjoy your life. So next person has to go and occupy second position, then the third person out of the remaining people go and take the third position. So in how many ways can we have some arrangements of 3 people, out of what do you call it now? Three people for a set of. Nowadays, can we have 20 people vie, right, for 3 prizes? In how many ways can we have 20 people vie for 3 prizes? So in how many ways can any of them, right, any 3 of them happen to be the one that would win the prize? So this is still a foundation problem. And then what do we do? So we're going to be having 20 permutation 3, right, which is then equal to 20 factorial divided by 20 minus 3 factorial. So we literally have 20 factorial over 17 factorial. And then this is going to give us 20 times 19 times 18 times 17 factorial. Everything divided by 17 factorial. 17 times 17. So we have 20 times 19 times 18, right? And that's going to give us, what was it? How many ways is that? 6, 8, 40 ways. 6, 8, 40 ways. Although I promised that I wasn't going to solve this like the way we've been solving it before, but like look at the logic again. Out of 20 people, the first person goes, right? So the first prize can go to any of the 20 people. So you have 20, first prize can go to any of the 20 people. But once the first prize is gone, right? Second prize can now go to 19 people. Any of the 19 people. Any of the 19 people, right? Then finally, the third prize can now go to any of the remaining 18 people, because 2 people are out. Any of the 18 people, so 20 times 19 times 18. And then the prizes are done because you have just 3 prizes. And this is also equal to like this. You see the logic, right? So that's the way it goes. Now, what if a contestant may win more than one prize? So if you look at it, so it means that the first situation we say you can't win first prize and then still go and win second prize. Do you understand? So if this is saying that a contestant may win more than one, it's just like what they do at the Headies or the Grammys, Okay, or maybe in football. So you can be the world best player. You can also like first in the world best player can win the Ballon d'Or, right? And then you can win the Puskas Award. Do you understand? Something like that, right? So that which means that you can win, you can be the highest goal scorer, right? So if you've taken the highest goal scorer, you can still go on and win the Ballon d'Or, right? The best player, right? And then maybe what else do people win? Maybe player of the match, maybe someone that won like the most player of the match or something. You understand that kind of a thing. So one person can win more than one prize. So which means that there are three different categories because it can't be the same category and then you go and win first, second. It doesn't make any sense. So that's the mental interpretation that this means that there are three different categories. So which means that for the first, so for B, the first prize, like the first category, Ballon d'Or can go to any of the 20 people. You understand? 10 times you are done. The Ballon d'Or, right? Because you can win more than one. If you can win more than one, so that means you are looking at the next kind of prize, the Puskas Award, which can still also go to 20 people. Then what will they give people again? Can I say player of the match or something? It shouldn't be. But anyways, so player of the match can also still go to any of the 20 people. So because he can go to any of the 20 people, do you understand? So that's why anybody can win because this first one now is maybe the person that won the one here that is coming to win the one here, right? That might still come to win the one here. But it may not win the third one, but like it may win like two of these three, or maybe even win the entire three. You understand? So the fact that you can win more than one means that there are three different categories of prizes. But if it says that you can't win more than one, that means it's a prize, but that has first, second, and third, position. So like that's how to interpret it. So in this case, 2 times 2 that is 8, then 8,000 ways. This is I'm kind of taking my time solving different examples so that you'll be able to you know understand the logic behind the whole thing. So now that we are done with this particular one, so we need to look at um permutations about a circle. Alright, so the next category is permutation, about a circle or a circular arrangement. Now the ones that we've been doing before, they are permutation on a straight line, right? On a straight line, that's one that we've been doing before. Right, all the one I've been doing before. If there is no specified manner, so if you are looking at the one on a row, maybe on a column, like just on a line, do you understand? And on a line, a position is distinct. Now let's say these are 6 seats, 1, 2, 3, 4, 5, 6, right? There are endpoints. This is first endpoint. This is another endpoint. A can sit down here. If A sit down here, C could be here, D could be here, E could be here, B could be here, and then F could be here. Do you understand? Now there could be a different set of arrangements. So in this case, it's still 6, but on this 6 seats, C is here, D is here, A is here, B is here, then what's this? A C D E. So E is here. 1, 2, 3, 4. Let's say F is here, for example. So if you look at it here, the neighbor to A is C, right? And there was nobody on his right hand side. But if you look at this place now, his neighbors are D and B. So like this is saying that is unique. Like this whole thing is unique. Do you understand? So any given position that you're seated at is a unique position. Like you can have any kind of person like around you, like beside you, towards your right hand and towards your left hand side. So it is unique, right? But for a circle, now for a circle, you have let's say there's this is a circle, right? So there's a seat here. One is a seat. 2, 3, 4, 5, 6. So imagine that you're at an event with 6 of your friends. So you can sit here, you can sit here, you can sit here, you can sit here, you can sit here. Now, for the first person, if the first person sits here, right? He has someone on his left hand side, someone on his right hand side. So it's not like this, like where you have people on this side, you have nobody on this side, like which is then unique from him being at the middle of somebody. So that's like the first person. Now the first person decides to sit here. It's the same scenario. Like he has somebody on his two sides, right? If the person decides to sit here, it's still the same thing. So like somebody here, somebody here. So which means that Wherever this guy chooses to sit, like, it's the same thing. So for the first guy, right, the way we are going to look at his own um, arrangement is different from the way we are going to look at this person arrangement. So literally, the first guy here does not really have a choice. Doesn't have a choice, because if you are the first person, I don't know if you've been to an event before where it's a table, like a round table, and you're like sat down here, then you stood up, sit down here, then you stand up again, like you sit down here. Do you understand? Like you don't like really know, because the whole thing is like the same thing. Do you understand? So that the first person doesn't really have a choice, so we don't count his own choice. So this is the next people. But once let's say this guy A sits down here, then others have choices, right? So if B decides to sit here, right? So D can decide to sit here, E can decide to sit here, F here, and then which one have you not mentioned? C can decide, to take the seat. So, but look at another situation. So you have 1, 2, 3, 4, 5, and 6. So if A decides to sit here, do you understand? A who doesn't really have a choice, right? It's facing, if it's facing here, do you understand? It doesn't really have a choice. Now this one, B can decide to sit here. B can decide to sit here. E can be here. C can be here. F can be here, and then A, D can be here. So others have choices. It's the first guy that doesn't have a choice. So which means that this is why when you are doing things that involve a circle, people sitting around a circle, the first guy doesn't have a choice. Do you understand? So its own formula is going to be n minus 1 factorial, because the very first person doesn't have a choice. So if you look at this, as in how many ways can 6 people, for example, sit around a circular table, right? A circle. So it's going to be 6 minus 1 factorial, which is 5 factorial equals 120 ways. That's going to be the answer, because the first person doesn't have a choice. His view is the same. You understand? His view is the same. Nothing is not unique to him, right? So, but once he picks a seat, the other somebody can say, "Oh yeah, I'll sit down beside A. I don't sit down beside A." You have a choice. You get it? Unlike here, A can say, "Okay, I want to sit down here. I don't want anybody close, like on my right hand side." It's a choice. That's a unique choice, right? F could be as, "Okay, I don't want anybody on my left hand side." That's a unique choice. But there's no unique choice there. Like you are going to have, people around you at the end of the day. So before others then begin to like make their decision whether they want to sit close to A or they want to sit far away from A. So yeah, so that's the logic behind arrangement about a circle. So that's that. So there are other examples that I want us to look at, which is still talking about a circle. So we have done this one. Okay, when we're done, second person and remaining people, we have this. Okay, I thought that was going to be different. Okay, well, so let's look at the third one. So there is, where is it? Where did I hide it? Page 4A. So yeah, ladies and gentlemen, in how many ways can 9 bits of different colors be strung in a circular ring, considering clockwise and anti-clockwise like directions, when others are distinguished and when they are not? So this is also talking about circles. So 9 bits of different colors. This is clockwise. This is the way your clock goes, right? And then this is going to be anti-clockwise. So this is clockwise. This is anti-clockwise. All right. So the first one says that you have to consider both, right? Um, when others are distinguished and when they are not. So if others are distinguished, clockwise and clockwise, so what are we going to do? This is an example what we call foundation that has to do with mirror images, right? So whether you choose to like go this way or choose like go this way, right? Anyways, if other is not distinguished, like any form that this thing comes, so if let's say out of the 9 bits, let's say there were 3 bits, and then you have like A, B, C, because strong they're like red, red, green, and blue. This is going to be like a different combination. It could be a permutation rather, a blue, red, a green, anyhow. Do you understand? Well, as long as it involves a circle and the others are distinguished, this is different from this one. So we are going to apply our formula 9 minus 1 factorial, which is 9 minus 1 factorial. This is going to give us 8 factorial. So whatever 8 factorial is, that's going to be our answer. But the second one says that when the others are not distinguished. Now, because this is is like a mirror, so if you face if you face the mirror, right? Your right hand side, if you're facing the mirror, your right hand side may look like your left hand side in your mirror, depending on how you stand or how is that the mirror in front of me right now. All right. So I'm shaking this part. There's this is it lateral vision or something like that. I just have that. I shake this part. You'll be facing. There's a way you face yourself. So which means that if we are not considering others, like if we are not considering others, now if you place this thing like this, red, green, blue, like in this direction, right? So if you are looking at anti-clockwise, which is here, this may appear as maybe like, how does it mean actually work? Like maybe like a red, green, blue. So it is like at least red is coming before green, coming before blue, red is coming before green, coming before blue. So at the end of the day, what you have here will be mirrored by what you have here. So instead of you like having this kind of thing, like an entire 8 factorial, it's going to be like half, like either ways, like it's going to be half of your former result, right? Because it's a mirror. So some things will look alike. So what is here? Instead of this one, like in the first situation, this permutation would have counted as one permutation. This one here would have counted as two permutation. But like look at it, red, green, blue, red, green, blue. Do you understand? So this is going to count as one. This one is going to count as like they are the same thing. Do you understand? They are the same thing. But although we are looking at 9 different colors, but I can't be drawing like 9 different colors now. So like they are the same, since they follow each other, it's the same. They are the same thing. Do you understand? Right? Even if they were blue, green, red, or something like that, because the question says that if others, are not distinguished. Do you understand? So they'll be the same thing. Do you get what I'm trying to say here? Right? So at the end of the answer to this is going to be n minus 1 factorial divided by 2. Right? But some of them, like it's not half of it, like it's not, instead of it to have one, do you understand? It's going to be half of what it's supposed to be because it's a mirror image. So the other one is not a different arrangement, it's the same of this one that's on this side. Do you get it? So at the end of the day, we are going to be having 8, 9 minus 1 factorial divided by 2. So our answer is going to be 8 factorials divided by 2. Please don't do 2 here, 1, 2 here, 8. I'm begging you. Okay, so which is okay, what's the if I did I even have a final answer? I just left it that way. So 20 equals 20160 ways. So whereas 8 factorial would be times 2 of that, which is 40,320 ways. It's 40,320 ways. That's that. So before we now move into our fifth example. For our fifth example, we'll be doing a different thing entirely, right? So let me just call this whole thing like a section 2, but this is not even going to be related to what we've been doing since. Okay, so in section 2 we have something like this. Where's it? Number 5. So in section 2 we have something like given that, so example 1. So given that 6PR equals 6, so find 6PR plus 1. So 6PR equals 6, find 6PR equals, so anyway, we know the formula. So this is going to be 6 factorials, right, divided by 6 minus R factorial equals 6. Okay, so first we have to get R for us to even know what R plus 1 is going to be. When we cross multiply, I'm going to be having 6 into bracket 6 minus r factorial equals to 6 factorial. Okay, but the good thing is that, this is 6 into bracket 6 minus r factorial equals 6 times 5 factorial. So that 6 will be able to cancel 6, like 6 will be able to cancel 6. Alright, so 6 minus r factorial is equal to 5 factorial. So these things are equivalent. So 6 minus r equals 5. 6 minus 5 equals r. R equals 1. So now that we've gotten our r, we can now find 6p r plus 1. Okay, because there's a second one that we need to calculate as well. So 6p r plus 1, that's 6 permutation 2. So 6 permutation 2 is just going to be 6 factorial divided by 4 factorial, right? 6 minus 2, 4 factorial. 6 times 5 times 4 factorial divided by 4 factorial. This takes this, then we have 30. Alright, so 6 permutation 2 is going to give us 30. Now the second one before we bounce is if n number 2, so if n permutation 4, where is it? We have if n perm equals 20, then n permutation 2. So we have to find n. This one is not difficult. So n permutation 4 is equal to 20 permutation whatever. So what's formula for n permutation 4? N factorial divided by n minus 4 factorial equals 20. Then this is going to be into bracket n factorial over n minus 2 factorial. So literally you have n factorial over n minus 4 factorial equals 20 n factorial divided by n minus 2 factorial. Oh my god, what is this leading to? So you have n factorial into brackets n minus, like cross multiply, n minus 2 factorial equals 20 n factorial, then n minus 4 factorial. So what is obvious is that n factorial we cancel n factorial, right? And then this guy actually could be written as this n minus 2 factorial, right? Could be written as n minus 2, right? N minus 3, n minus 4 factorial. So all of this would then equal to 20. So all of this equals 20 n minus 4 factorial. So we can divide both sides by n minus 4 factorial, n minus 4 factorial. This guy takes away this guy, this guy takes away this guy. So what two numbers can we multiply? No, this is already the quadratic equation. Right, so I'm thinking minus 7 plus 2, minus 7 times 2 is going to give us minus 7 plus 2. So we have n squared plus 2n minus 7n, right? Minus 14 equals 0. Factorization method. So n can just do this. So n into bracket n plus 2 minus n into bracket 7n minus what? Minus 7 into bracket n plus 2 equals 0. So from here, n minus 7 equals 0, comma, n plus 2 equals 0. So n equals 7 or minus 2. So as far as permutation is concerned, n cannot be minus 2. So our answer, n equals 7, is going to be the right one. So n has to be 7. So yeah, that's about that. I just said let us chip that in, right? So for us to know how to also approach questions like this. So yeah, what we have to talk about next is our assignments. If you don't understand, the comment section is there, and you can go over and over the class again to ensure that the whole thing sticks. And please solve more exercises even beyond the assignment that you're going to be given. So find the values of 6 permutation 5 and then 18 permutation 10. That's number 1. And number 2, find how many different arrangements are there in gold medal. If I, there are no restrictions on the order of letters, and I, if the two letters D come first and the two letters L come last. Now you've been needing the understanding of the previous lesson to be able to solve that. So if you've gone through that lesson before, of course you'll be able to solve this one. If I think I mentioned that if the two letters D must come first and then the two letters L must come last. Now for 3, n permutation 6 equals 120 n permutation 3. So find n, then
I don't know if you might get a decimal or something. I just came, I just brought it up like by myself. So just solve it right, and whatever I get, just leave it like that. I just came up with it. Now B, 20 permutation R equals 6.84 times 10 to the power 3. Find R. Then 4 is actually the easiest. Express 37 times 36 times 35 in terms of factorials. It's not hard. Okay, let me just help you out. So if you have to express like 5 times 4 in terms of factorials. So it's going to be 5 times 4 times 3 factorials, then divided by 3 factorials. So when 3 factorials cancel 3 factorials, you still have your 5 times 4 back. So I've kind of given you the idea of how to solve number 4. So yeah, that's that. Next lesson, we're looking at combination. I hope to see you there. So bye.